For our introduction, direct proof employs the method of assuming the hypothesis to be true, and then logically deducing that the conclusion is true, using known facts. While the indirect proof, whereas, hangs upon the idea that assuming the conjecture to be false will lead to a contradiction, which in turn leads to the case that the conjecture should be true. We have given conditional statement here. If n squared is even, then n is even. We can prove it directly or indirectly. So to prove it directly, we assume that the hypothesis statement to be true and use it to show directly that another statement, which is the conclusion, is true. Suppose that n squared is even, then n squared is equals to 2k. Let n equals to 2b. b is an element for some integer. Therefore, we use the n squared, and the value of the n is equals to 2k. Now, n squared is equals to the quantity of 2k, quantity squared. To solve this, it turns into 4k squared. Since 2 squared is equals to 4 and k squared is equals to k squared, then next we're going to create a product of the 4k squared. The product of the 4 is 2. As we can say that 4 is divisible by 2. Then now we get that 2 is the quantity of the 2k squared. And let the 2k squared equals b. Now we get the value of the n is equals to 2b. And it is true that n is equals to k, which k is b, is the element of the some integers. Now to prove the statement indirectly, we can use to assume that the conclusion is false. We show that the assumption leads to contradiction. So our hypothesis here is even. So we're going to assume that n is even. Because here in indirectly proving or proof is that since assumption false, conclusion must be true, that the conclusion is not even. So here assume that n is odd, and also n squared is odd. So we use the n squared here. The value of the n is odd, which is 2k plus 1. And then in n squared, we have 2b plus 1, where b is the element of some integers. Now, to solve this, let us try to solve the n squared, which is the value of the n is 2k plus 1, right? So we're going to use this. So it equals to the quantity of 2k plus 1 quantity squared. Then the result would be 4k squared plus 4k plus 1. It is because we create a product of the quantity of 2k plus 1 quantity squared. Now let us also form a product of the 4k squared plus 4k plus 1, since as we can see that 4k squared plus 4k is divisible by 2, we can use to create a product on it, so that we can eliminate the sum of the integer into a variable, which is the variable that we formed from the n squared, from the n squared, n squared, which is the n squared is equals to 2b plus 1. since b is the element of some integers, right? So the result here is 2 is the quantity of 2k squared plus 2k then plus 1. Then let some integers equals to b, as we stated from the n squared is equals to 2b plus 1. Thank you for listening. When you are proving the even is equals to 2k, and then the odd integer is 2k plus 1. then it is true that when we contradict to the statement which is we assume that n is odd and n squared is odd also, then the final answer is 2b plus 1, and our conclusion here basis on our assumption is true. As we can see to the value of the n squared, which is n squared is equals to 2b plus 1.